Welcome to Missing the Mark, where we look for meaning in strange places. I'm Christopher. Today I want to look at probability, what it is and isn't, because it is a very abused concept in the modern world, including even in some scientific contexts. It gets especially abused in pseudoscientific contexts, like promoting diets that will make you sick and fat. It also gets very abused in debates about history, religion, economics, politics, sports. In fact, there aren't many places where probability doesn't get abused. The basic point that I'm going to explain is that the mathematics of probability don't actually apply to our world, or in fact to any world substantially similar to ours. But first, I'd like to make an absurdly basic point about mathematics that we'll use later, and it's this. All of the statements of mathematics are hypothetical. They're all of the form, if a closed figure has three sides, then it is a triangle and the sum of its interior angles adds up to 180 degrees. If it does not have three sides, or if it is not a closed figure, this statement does not apply. If it is a square, that is not close enough. If it is kind of triangle-shaped, the mathematics of triangles tells you nothing about it. The same goes for utterly misusing terms. You may recall that in a right triangle, the side opposite the right angle is called the hypotenuse. If you say that the hypotenuse of a circle is its biggest side, you are simply saying nonsense. Fancy nonsense, but the words you used, in the order you used them, do not mean anything. Now, words like hypotenuse are normally used by professors with impressive degrees who use words correctly, so the words have an aura about them. But for all that, if you argue that a circle has properties on the basis of facts about a triangle, you might as well say pizza, tree, shrimp, grass, nozzle, Wookie. It is just sound in the air and nothing else. Sound and fury signifying nothing, if you want to be more poetic about it. The point is obvious but important. If you use mathematical concepts, you must use them correctly, or not at all. So bear this in mind when we talk about probability. It is possible to say fancy-sounding, esoteric words and still be saying nothing at all. So what is the problem with probability? Why does it not apply in the real world? Because the real world is finite. Nothing goes on forever here. And, some really specialized definitions about measure spaces aside, probability is defined entirely in terms of infinite sequences. Let's consider the statement, the probability of a fair coin coming up heads is 1/2. There are colloquial interpretations of this I assume everyone is familiar with, but what does it actually mean, mathematically speaking? Well, this is what it means. Suppose each time you flipped a fair coin, you wrote down the number of times it came up heads divided by the total number of times you flipped it. So that this isn't tedious, I've already done it a few times and this was the result. The sequence of coin flips produces a sequence of numbers. Mathematical probability is a statement about these numbers and about nothing else. Moreover, it is an extremely limited statement about these numbers. They might go anywhere for arbitrarily long stretches in the sequence. There is literally nothing you can say with certainty about the first million of them. You can of course say things about yourself, such as that you would be very surprised if the first million happened to be all heads, but talking about oneself instead of the world around one is not a virtue. About the numbers, you can say nothing except that they must all be between 0 and 1. What probability does say about these numbers is that they will eventually get arbitrarily close to 1/2. Formally, it's a limit, which just means that for every real number, call it epsilon, greater than 0, there is some point in the sequence after which all of the numbers are within epsilon of 1/2. It might be very, very far in the sequence. For a small epsilon, it could well be long after an element whose index has more zeros in it than there are stars in the sky and grains of sand on the beach. Which cannot happen in the real world because you will not be flipping coins past the heat death of the universe. You'll probably have to stop even sooner than that. So when somebody tells you that there was a study that proved something with a p-value less than 0.05, all this means is that if there was no connection between the thing studied and the effect they found, and you were to run the study they did infinitely many times, eventually the fraction in which they got the results they did purely by chance, compared to the total number of studies they ran, would be less than 1/20th, that is 0.05. That is literally all it means, and so far no one has run any study infinitely many times. They are telling you facts about something which has never happened and never will happen. It sounds impressive in practice, mostly because everyone agrees to be impressed by it. If I were cynical, I would point out that when it comes to published studies, people who live by publishing have a strong interest in making sure that the standards for publication are low enough that everyone gets to publish regularly. Indeed, there's a lot I could say about this, if I were cynical. But what actually interests me more is probability applied to other areas of life, like the fact that events with probability 0 happen. For example, what is the probability of Richard Dawkins having been born? Bear in mind that each person is unique, and there is only one Richard Dawkins. So let's look at the numbers. As more and more people are born, what proportion of them are Richard Dawkins? Well, for a long time it was 0, then it blipped up slightly when Richard Dawkins was born, then it trended back to 0 again as more and more people continued to be born. Thus the probability of Richard Dawkins being born is, mathematically speaking, 0. That doesn't mean it never happens, it only means that it happens finitely many times. That's the proper interpretation of an event having probability 0. In an infinite sequence of events, you only expect it to come up finitely many times. Events with a non-zero probability will happen infinitely many times, which is why infinitely many monkeys typing on infinitely many keyboards will produce the collected works of William Shakespeare not just once, but infinitely many times. Now, to bring my point into focus, probability means nothing in our world, and it means even less when applied to single, unique events. Probability can be a very useful heuristic when dealing with extremely large collections of events, like insurers building actuarial tables to figure out what to charge people for insurance. Insurance companies do go broke sometimes from unlikely things happening too close together, but infrequently enough that people are willing to invest money in them, which is their actual purpose. But when it comes to unique events, probability is not even useful. Unless you're abstracting things into arbitrary categories, all of history is made up of events with a probability of 0. This is why truth is stranger than fiction. This is also why David Bentley Hart's friend might have been right in characterizing Richard Dawkins' argument for why there is almost certainly no God as possibly the single most incompetent logical argument ever made for or against anything in the whole history of the human race. If you haven't encountered it, Dawkins' argument is basically that God would have to be more complex than everything else that exists, and since the more complex something is, the less likely it is to exist, God being almost infinitely complex means that he almost certainly doesn't exist. Setting aside the catastrophic misunderstanding of God, just to begin with, Richard Dawkins has apparently proven impervious to the idea that God is simple, not made of separable parts. The argument would still prove exactly nothing. At absolute best, and this is being charitable beyond the bounds of reason or honesty, it would prove only that in infinitely many universes without a real God, a complex pseudo-God would happen infinitely many times, but as a vanishingly small proportion of the total number of universes. That is to say, pretending that it is not fatally flawed for several other reasons, it still does not prove anything at all about our universe. In fact, it wouldn't even suggest anything, because our delicately balanced universe is monstrously unlikely in a universe that lacks both a real God and even a pseudo-God. This is why some people will entertain the idea that we're actually a simulation in somebody else's video game. The programmer of that simulation would be a Dawkinsian pseudo-God to us. Silly as this is, it is a better understanding of conditional probability than Dawkins' evidences. But it's still nothing like proof, because being inside this universe, we have only this universe. And probability says nothing at all about one-offs. As I said, probability can be a useful heuristic, as long as you don't trust it too far, but it is no substitute for knowledge. In general, it is best when used in a purely negative way, highlighting how something which might look like a real connection may actually just be mere coincidence. Probability is worse than useless. It is actually harmful when it is treated as a way of turning ignorance into knowledge. If you want to know something about the real world, you're stuck doing the hard work of actually investigating it and thinking about what you found. That's all for now. Until next time, may you hit everything that you aim at. Welcome to Missing the Mark, where we look for meaning in strange places. I'm Christopher. Today I want to look at probability, what it is and isn't, because it is a very abused concept in the modern world, including even in some scientific contexts. It gets especially abused in pseudoscientific contexts, like promoting diets that will make you sick and fat. It also gets very abused in debates about history, religion, economics, politics, sports. In fact, there aren't many places where probability doesn't get abused. The basic point that I'm going to explain is that the mathematics of probability don't actually apply to our world, or in fact to any world substantially similar to ours. But first, I'd like to make an absurdly basic point about mathematics that we'll use later, and it's this. All of the statements of mathematics are hypothetical. They're all of the form, if a closed figure has three sides, then it is a triangle and the